Welcome to ModPath Chat, the official podcast of modern pathology, featuring interviews with authors and experts on the latest science, technology, and developments in the field of pathology. Your host, Dr. George Netto, is the editor-in-chief of Modern Pathology and the chair of pathology at the University of Alabama at Birmingham. Here's Dr. Netto.
Welcome to ModPath Chat. My guests today are two distinguished speakers and experts in the field of digital paths, and I promise you're going to enjoy this one. So they are Professor Inti Zlobec. She is a professor of digital pathology at the Institute of Pathology in Bern. She's also a member of the executive team for the Center of Artificial Intelligence in Medicine, CAIM, and a president of the Swiss Consortium of Digital Pathology, clearly a leader in the topic that we're going to discuss today. And that's not enough. She has even more time. So she took the role of chair of European Society of Pathology Working Group on Digital and Computational Paths. So we thank you for all that. Dr. Amjad Kahn is an expert, one of these whiz that we're so glad coming from engineering crossing to pathology. He's an expert in deep learning, computational diagnostics, and his research interest is integration and validation of AI tools that will help us as clinicians in digital diagnostics routines to assist us for tedious and cumbersome tasks. Who wouldn't love to have people like Amjad take away all our tedious and cumbersome tasks? So that's actually what the paper does. And the paper that we're going to discuss, that study we're going to discuss, was just accepted in Modern Pathology about computer-assisted diagnosis of lymph metastases in colorectal cancer. So welcome on board, and thank you very much for accepting my invitation.
Thank you very, very much for having us here today. It's really a big pleasure to see you again, George.
Yeah, thanks a lot for a lovely invitation.
Thank you. It's a pleasure. And as Inti mentioned, you're a repeat offender. So now this is the second time you're on podcast, which tells you something about the importance of the great work you're leading. And as a field, we're grateful to you. And for Modern Pathology, on behalf of Modern Pathology, I thank you for the great studies you submit to us. So let's start with maybe Amjad, and you can both address any questions you want. This is very informal. Amjad, tell us why you did this. What triggered you to do that?
Yeah, I think it's a very interesting question. Maybe there is a little story behind this. So this is like whole project is my PhD project. So I choose to do this because I had some other offers when I was looking for my after my master's, like something to do. So I realized that like there are a lot of works, like in AI, like in medicine especially, but expert they are not using it. So always I have questioned like why there is a gap, how to fill this gap. And as you started like cumbersome and tedious jobs, so that was the main motivation for us, since pathologists always complain about the number of slides or more and more when it comes to diagnose or to assess the lymph nodes.
And maybe I can just add to this, because it's no longer the day where it was the minimum of achieving 12 lymph nodes. Now, when we have these colorectal cancer resections that are coming in, you might have 40, 50, 60, 70 lymph nodes that need to be evaluated. And so, we just thought this would be a perfect example to try to transform what started off as a research project into something that could actually be implemented and used in as a support tool, perhaps for the daily routine. So it was basically the perfect scenario. Yeah.
Excellent. So hopefully, while maintaining accuracy, as we're going to see, increase efficiencies and give pathologists more time to focus on important tasks where really their expertise is needed. And I agree. I mean, not just the number of these fragments that Amjad referred to. It's always the biggest risk, because on the section you can miss the fragment that had the pertinent option, meds and pertinent finding. So wonderful. So how did you go about, like everything else? I know there is a training set and fine tuning. Can you walk us briefly through the design of the study?
So we applied like two-stage approach. So we want to identify where are the lymph nodes in our workflow, which we targeted to develop. So in the first stage, the algorithm should identify where are those fragment regions which are called lymph nodes. So for that, the pathologists help in order to annotate. We train the segmentation model for that. And then there was a question like how we can go for the metastasis detection part. So we look around some data, and like the regional annotations are cumbersome, so we cannot do like a very large amount which is normally required by the deep learning. So we look around and we saw this chameleon data is available, which is already annotated, and we discussed with our pathologist that do you see any morphological differences while diagnosis between the adenocarcinoma coming from the sentinel lymph nodes as well as the CRC. So I think the answer of the question led us to do some experiments in order to train the model for metastasis detection, which we compared in the paper to see like how what are the differences when we apply the model trained only on the breast and then we apply the same model on the CRC data. So there were differences, and then we try to get fine-tuning idea in order to fine-tune with the very small data of the CRC data, which were directly annotated by the pathologist in-house. And then we got like a very good performance on the CRC, which was the actual target.
That's interesting. I mean, to me, and that caught my eye, and I'm glad you mentioned that, is that because as we go further, there'll be different organs, and you don't want to start from scratch. So, Inti, how valid is this? So chameleon is on sentinel lymph nodes, breast. So you're using whatever you develop there, you can flip it with fine tune it for another organ. Is that
correct? And that's exactly our next plan. Is of course not to stop at colorectal, because now we have something nice for. That was originally obtained from breast to colon. And now we'd like to go further, of course. So, one of our next targets might be head and neck tumors, lymph nodes of the head and neck, or other areas. We don't expect that this will be something very different. Probably we will still need to get a small amount of annotations, again, to fine tune the algorithm for the specific entity. But we think that probably the biggest hurdles have already been overcome. It's probably very transferable and translatable to other lymph node types as well from other, around the body. So I think we'll probably have, we'll see what happens, but it's definitely in our plan to continue further with what we've done so far, using a similar technique.
So after you back to so after you did that was like 100 whole slide images I see, and you mentioned the chameleon, and now it was time to do some. I'm impressed that there was 4 independent cohorts that you validated in. That's and then 2 of them 3,836 slides. That's a lot of slides. So tell us about that.
This also, by the way, before Amjad may mention it, something about this underlines the importance of the collaborative spirit when it comes to working with algorithms, because one institute by itself is probably not going to be able to generate the amount of data that you'd sort of like to use for the different steps in getting to an algorithm that you can say, okay, we feel very confident with this algorithm. And the more kind of data that it sees coming from different institutes, the better. So we were very fortunate that, we have a very close collaboration with the people from Radboud, UMC. And so there is a large cohort that came from their study that we could also incorporate into ours, and vice versa. So we tend to share a lot of data. And that I think is a very important thing. So here too, our external validation cohort was a cohort that came from Radboud, and for our internal validation cohorts and the ones that we were using for the whole algorithm development also came from different time points. We did really a sort of systematic consecutive series of cases that came in from the last few months. And we went also back in time a little bit to collect, lymph nodes from earlier times. So also trying to top up cases with mucinous tumors, with signet ring cell cancers, to try to sort of get that exposure and see how the algorithm will react in sort of standard cases, let's say.
So yeah, and so if I if I understand it, the advantage of having some external and different institutions is stains is different, the artifacts could be a little, and you want something that is generalizable because you're not making the tool and algorithm just to use in your institute, hopefully.
Absolutely.
So that's correct, right? So the more variability is better.
Absolutely, because I mean, even though of course we are the first people to develop it internally here, but that's not our end goal. We would like that if it helps other institutes and they would like to use it, that they'll be able to take it, maybe also fine tune it for their own. There are some color variations, of course, that they might have. Maybe there are some different protocols that are used. Maybe the tissues are being cut at a thicker, thinner. There might be some slight variations, but I mean, at the end of the day, we're producing this so that others will also be able to use it.
We'll circle back to that. So Amjad, tell us how well did it work when you did all this amazing work? How well the accuracy and sensitivity, specificity, and
I think we were focused on there were two tasks within this. First, because we are not segmenting the metastases inside, because we are classifying small tiles within the fragments, because we cannot input or train the deep learning on a very big image due to the memory restrictions. So we, for the tile base, in order to see the performance on the tiles or the patches, so we use AUC normally to see how the model performs because we ensemble two different models and we want to compare with individual as well as the ensemble model to see whether we have some sort of performance measure which could help or improve. So in that regard, we use AUC in order to monitor the performance during the training as well as on the validation of the test cohort. And then we also measure the sensitivity and specificity, which are normally used by the pathologists extensively in the clinic. So I think on AUC, we were very happy when especially we saw the performance on the ensemble model as well as on the fine tuning steps. So which was very clear to us, the model is going in the direction where we want. And on the sensitivity and specificity was on the global scoring of the whole slide image, where we can bring on we went to the narrow down over approach from segmenting the lymph node, and then we go to the micrometastasis search, and then for the global score we have to come back actually to the global scoring. So for that we aggregated those tiles in order to produce the global score, whether the slide is positive and negative. Eventually we have to compare the global scoring of the diagnostic reports done by the pathologist, because these cases were from the previous years most of the time.
So the figures you mentioned, which is 0.995 and 0.967, these are for the global. So this is how sensitive you're going to catch over 99%, 99.5% of positive slides, nodes with positivity, you're going to catch them. Is that correct?
Yeah, exactly. So these are the global scoring results. Yeah,
that's pretty amazing, and especially with such a specificity. Then, and I think Inti already you touched upon that. You wanted to try the different subtypes, as now the WHO, mucinous signet ring histology, things that can give you problems. So I was intrigued to see that you dropped a little bit on sensitivity and specificity in those. So how we're going to deal with that down the road?
I think that's almost was expected, because there was not so much training data that actually included those sort of special subtypes. So we could go now and sort of try to help to perfect the algorithm even more and keep adding those sort of not so usually seen subtypes to sort of retrain the algorithm with. But I think that it's already performing very well with almost no exposure, let's say, to that kind of data in the training set. So I'm pretty confident that if we keep adding some slides there, we'll also reach a very high accuracy there.
I love the optimistic attitude and positive. So yeah, because I mean, you're right. It's 87% sensitivity even on signet ring and mucin. I can tell you, we missed a lot of signet ring. So the computer is doing very, very well here. So wonderful. So I guess and so we're nearing the end of our time. Let's one more, a couple of more points I wanna highlight. I take it from our conversation you're starting to use it in your own institute right now? Is that correct?
So this is very nice because one thing is, of course, to just have the algorithm. But the other thing is, how are you supposed to use it? And how can pathologists really use it in a way that is meaningful to them? So we have another colleague, Stefan, who together with Amjad was able to create an interface, a user interface, where you basically scan your case number, and the slides will actually be, so they're scanned downstairs, so downstairs meaning in our lab. We're going to send those scans directly to the HPC cluster of the university. The algorithm is going to run on it. It will produce results. Those results come back into this interface. And then you as pathologists will go into this interface and you can basically lock in your scores, because we don't want that for the moment that anybody is bypassing the real evaluation, primary diagnostic. We don't want that. Our boss especially made it clear.
Thank you.
We're not doing that. But you lock in your score, and then you get to see what the algorithm said. And then you can go and also ideally correct the algorithm if it's incorrect, or you get to see the discrepancies and maybe change your own scores. And so by doing this, we've sort of also made it now a really kind of flexible, easy to use interface that you can essentially click on the icon of the slide, if it's a slide A, B, C, change the value if it's positive, negative, or you have a discrepant opinion. And in the end, we hope to see that we can identify the discrepant cases, feed that back into the system, and then that will continuously improve the algorithm. So this is not a CE-IVD approved system. We don't have an image management system even in our institute yet. So this is outside of that whole workflow. We've created this kind of standalone, and we think that that's exactly what we can also give to other institutes. When this is done and validated here, with our pathologist, Bastian Dieslich, who's working very heavily on optimizing this interface, and he will be the first one to work with the team. When it's done and it's validated, we plan to just publish this and say, let everybody who wants to use this interface for their own purposes, and ideally would also publish our data. So if everybody would like to use the scans and images and make everything freely available, open source for everyone, yeah.
But I mean, explain to me, you just mentioned using your high performance computing, your HPC downstairs and sending. So if I'm logging in from here and uploading the whole slide image of my bladder mets, hopefully you'll go to bladder next, and look at all these nodes, because in bladder too, we need to do more and more nodes. But all jokes aside, if you're uploading, it's not going to tax your system, or do we have to upload we're going to have to download the algorithm to our own system and use it? How is that going to work?
Yeah, this is a very good question. I think we haven't yet elaborated so far what's going to happen.
Be careful what you wish for. You may overwhelm it.
But ideally, we give you everything, and then for whatever setup is, we have to think for your setup, how of course that could work. But we're very much open to, to just sharing what we can produce here. So
great. And I think we're going to have you a third time as just to discuss in general the topic of digital and where the future is going, because heavy on my mind. So first, I'm glad you said that the pathologists will still be involved and click, validate. I think if it just does that, go to the areas where it's suspicious or thing is met and validated and have to override if there is any error. I think that's critical, at least in when we start using such systems. But the other thing is this open source issue versus commercialization, and where are we going to have to buy every single lab algorithms, one for HER2, one for METs, one, and you can see where the cost, even if it's a subscription based, even where the cost can be prohibitive. But these are conversations we're going to have you maybe and other experts and discuss this, because this is coming. And Amjad, congratulations on your work and your publication. We're honored as Modern Path to have your PhD publication with us, and I'm sure this is going to be widely cited and read. And I thank you both again for accepting my invite.
Thank you so much for having us. Really, it was a pleasure. Thank you.
Any opinions expressed in this podcast are the speaker's own and do not represent the views of Modern Pathology, Springer Nature, UAB, or USCAP. Your ModPath Chat host and scientific director is Dr. George Netto. Producers are Christina Crow, Amber Jackson, Dr. Sarah Jang, and Dr. Catherine Ketchum. Technical direction is provided by Kaminsky Productions, music by Mitch Neubauer. Thanks to the authors, reviewers, and editors of Modern Pathology for making this podcast possible.